Bismillahirrahmanirrahim. In this lecture, I am solving problem 3-95E from the book Thermodynamics and Engineering Approach by Cengel 9th edition. So the statement of the problem is a refrigerant 134A at 400 psia has a specific volume of 0.1144 cubic feet per pound. So in given data, refrigerant is used R134A. Pressure is given to us as 400 psia pound per square inch absolute, and specific volume is 0.1144 cubic feet per pound mass. Required is to find temperature by three methods based on find temperature, based on number A, the ideal gas equation, number B, the van der Waals equation, and number C, the refrigerant table, van der Waals equation, and number C, the refrigerant table by three methods. So first we find by ideal gas equation solution. Number A, we will find T by using ideal gas equation. So according to ideal gas equation, PV is equal to RT. So to find T, rearrange this equation. T is equal to PV divided by R. Pressure is given to us as 400 psia and specific volume is 0.1144 cubic feet per pound mass, and the value of R per refrigerant 134A is 0.1052 psia. This is constant value, cubic feet per pound mass and per degree R. So degree Rankine. So temperature will be psia will be cancelled with psia, cubic feet will be cancelled with cubic feet, pound mass. This is per degree R, so this is final unit. And simplify this, so temperature will be equal to 434.98 degree R. This is the answer from ideal gas equation. Now number 2, find the temperature by van der Waals equation. So van der Waals equation is P plus A divided by V square. This is PV is equal to RT, and this V minus B is equal to RT. This is just like PV is equal to RT, and this is this term A by V square and minus B. These are for correction to because all the gases are real, and PV is equal to RT is equation for ideal. So this is close to real. So the result of this will be more accurate as compared to this value, as compared to ideal gas equation. So P plus A by B square is equal to V minus B is equal to RT, and A and B are constant. Now here A is equal to A is constant 3.596, put power 6 into psia per pound mass square. Similarly, B is equal to 0.01504 cubic feet per pound mass. So putting values, so T is equal to, this is RT, so both are divided by R, so T is equal to 1 over R from this equation. T is equal to 1 over R into P plus A divided by V square into V minus B. So T is equal to the value of R per R134A is 0.1052 psia cubic feet per pound mass per degree R, and to P plus A divided by V square. So P is 400 psia plus A divided by V square. So the value of A is 3.596 foot power 6 into psia per pound mass square divided by V square. So the value of V is 0.1144 whole square, and the unit of V is cubic feet per pound mass. So this is square, so feet power 6 per pound mass square, because this is the square. So square of feet per feet cube per pound mass is feet power 6 per pound mass square, and to V minus B. So the value of V is 0.1144 cubic feet per pound mass minus 0.01. The value of B is 0.0. This is the value of B, 1504 cubic feet per pound mass. Now further simplify this. So T is equal to 1 over 0.1052 is equal to 9.5057, and this is in double unit is in double division. So this will be equal to pound mass degree R divided by psia into cubic feet, and to 400 psia, and this cube feet power 6 will be cancelled with feet power 6. Pound mass square will be cancelled. Final unit will be psia, and the result of this will be equal to 274.7689 274.7689 psia, and to 0.1144 minus 0.01504 is equal to 0.00936, and the unit is cubic feet per pound mass. Now further simplify this. So T is equal to 9.5057 pound mass into degree R psia into cubic feet, and 400 plus 274 is equal to 674.7689 psia multiplied by 0.00936 cubic feet per pound mass. So pound mass will be cancelled with pound mass, cubic feet will be cancelled with cubic feet, psia will be cancelled with psia. So final unit is degree R. Multiply these three below. So final answer is 637.3 degree R. So this is the answer of van der Waals equation, and this is more accurate. The answer of ideal gas equation is 434.98, and this is 637. So this is more accurate as compared to above. And part number 3, by using refrigerant table. Point T, by using a refrigerant table. So pressure is given to us as 400 psia, and volume is given to us as 0.1144 meter cube per kg. So So we can find temperature with the help of pressure and volume. So first we check whether our properties are stayed in the wet region, mixed region, or in superheated region. So according to our from saturated table of R134A, from saturated table of R134A, at pressure is equal to 400 psia, find Vf and Vg. So go to the saturated table of R134A and 400 psi. So this is saturated property of R134A, and this is pressure. So check here 400. So this is 400.28, approximately equal to 400. So here Vf is 0.016 and Vg is 0.0964. Vf is equal to 0.016 cubic feet per pound mass, and Vg is equal to 0.0964 cubic feet per pound mass. But the value given to us is more than Vg, as V is greater than Vg. So refrigerant is superheated. Refrigerant R134A is superheated. So we will use superheated table of R134A to find temperature. So from superheated table of R134A, at pressure is equal to 400 psia and specific volume is 0.1144 cubic feet per pound mass. Find temperature. So go to superheated table, check 400 psia and specific volume. So this is superheated table, R134A superheated vapor, and this is pressure 400. So check here volume 0.01144. This is 0.11146, almost equal to 0.1144. Very negligible difference. So there is no change if we do interpolation. So there will be no change. So this is 200 degree Fahrenheit. In front of this temperature is 200 degree Fahrenheit. So temperature is equal to at 400 psia and specific volume, and the superheated table of R134A temperature is 200 degree Fahrenheit, and convert this to degree Rankine. So this is 200 plus 400, which is equal to 600 degree Rankine. So this is the final answer. We find temperature by three methods. And this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.